Welcome to the Explainer. Today, we're going to build a mathematical toolkit. We're going to take those complex expressions, the ones that always pop up on exams, and learn exactly how to break them down, piece by piece. By the end of this, you'll have the tools you need to really master polynomials and factorization.
So, this is our mission for today. An expression like this, it can look a little intimidating at first, but I promise you, it's really just a puzzle waiting for us to solve. And in the next few minutes, we're going to learn the exact method to crack it, step by step.
And here's our game plan. First up, we'll get the basics down solid. Then we're going to add two incredibly powerful theorems to our toolkit. After that, we'll use those tools in a full-on factorization masterclass before we wrap things up in the exam prep zone to test your new skills. All right, let's dive into section 1, the basics. Before you can build a skyscraper, you need a really strong foundation. So let's make sure we're all speaking the same language. So what in the world is a polynomial? Well, the formal definition is right there, but let's break it down. Really, it's just a mix of numbers and variables, like x. But here's the one key rule you gotta remember. The powers, those little exponent numbers, have to be positive whole numbers. No fractions, no negative numbers up there. That's it. Now, this chart shows how we talk about polynomials. We basically classify them in two ways. First, by degree, and that's just a fancy word for the highest exponent you can find. A degree of 1 is linear, 2 is quadratic, and 3 is cubic. Simple enough, right? The other way is just by counting the terms. 1 term is a monomial, 2 is a binomial, and 3 is a trinomial. It's all just vocabulary to name what we're looking at. Okay, this right here is a super important idea, the zero of a polynomial. Sometimes you'll hear it called a root. All it means is finding a number you can plug in for x that makes the entire expression equal 0. And trust me, finding these zeros, well, that's the whole secret to solving these polynomial puzzles. Let's move on to section 2. It's time to add the first major tool to our kit. This is the remainder theorem, and it's an amazing shortcut for division that is going to save you a ton of work. Okay, I know that definition sounds pretty technical, but the idea behind it is so simple and so clever. If you want to know the remainder when you divide a polynomial by something like x minus a, you don't actually have to do all that long division. You just take that number a, plug it into your polynomial, and whatever answer you get, guess what? That's your remainder. It's like a magic trick. Let's see this thing in action. We want the remainder for x cubed plus 1 divided by x plus 1. Okay, step 1. Find the 0 of the divisor x plus 1. Well, that's just negative 1, right? Step 2. Now we plug that negative 1 into our polynomial. We get negative 1 cubed plus 1. Step 3, let's calculate. That's just negative 1 plus 1, which equals 0. And that's it. The remainder is 0. Done. No long division, finished in seconds. How cool is that? And you know what? That remainder of 0 we just found, that's a huge deal. It's the perfect setup for our next tool, which is the real key to unlocking factorization, the factor theorem. This slide just nails the connection between the two. The factor theorem isn't some brand new idea. It's just a special version of the remainder theorem. Think about it like this. When you divide 10 by 2, what's the remainder? It's 0, right? And that means 2 is a factor of 10. It works the exact same way with polynomials. If our remainder is 0, then the thing we divided by has to be a perfect factor. The big takeaway here is that this is a two-way street. If you plug in a number and the polynomial becomes 0, then you know x minus that number is a factor. And it works in reverse. If you already know that x minus a is a factor, you can be 100% sure that plugging in a will give you 0. It's a super powerful check. Section 4, your factorization masterclass. All right, this is the moment we've been building up to. We've got our foundation, we've got our tools. It's time to go back and solve that puzzle from the very beginning. Okay, let's do this. Factorize x cubed minus 2x squared minus x plus 2. Step 1. We use our factor theorem to find the first piece of the puzzle. We just test some simple numbers, like 1. Let's try it. And bingo! Plugging in 1 gives us 0. That means x minus 1 is our first factor. Step 2. Now we divide our original cubic by that factor we just found. This leaves us with a much simpler quadratic, x squared minus x minus 2. Step 3, we're on home turf now. We just have to factor this quadratic, and that breaks down pretty easily into x minus 2 times x plus 1. And finally, step 4, we just combine all our pieces. The final answer is x minus 1, x minus 2, x plus 1. And just like that, puzzle solved.
And here's a pro tip for your exams. Think of these algebraic identities as power tools for factorization. For certain problems, they let you jump straight to the answer. I seriously recommend memorizing these. They will save you so much time when the clock is ticking. And that brings us to Section 5, the exam prep zone. We've built the toolkit, we've walked through the masterclass. Now it's time to put those tools to work and really make sure this knowledge sticks. Let's do it.
So let's do a quick-fire recap of our polynomial toolkit. A polynomial, just an expression with positive whole number exponents. The degree, that's just the highest exponent. A zero, that's the magic number that makes the whole thing equal 0. The remainder theorem is our amazing shortcut to find the remainder. And the factor theorem tells us if that remainder is 0, we've found a factor. Our method is simple: find a factor, divide, and then factorize whatever is left.
Okay, time to see what you've learned. Here are some easy questions just to get you warmed up. Go ahead and pause the explainer right now, give them a try, and see how you do.
Feeling good? Awesome! Let's crank up the difficulty just a bit. These medium-level questions are going to require you to really apply the theorems we've covered. Go ahead, pause here, and give them your best shot.
All right, for those of you who really want to push yourselves, here are the difficult questions. These are designed to test your deep understanding of how all these concepts fit together. Pause the explainer one last time and really see what you're made of. You know, the mathematician Paul Holmos once said, the only way to learn mathematics is to do mathematics. You've got the tools. You've seen the method. You've got the practice problems. You have everything you need. Now, go become a master.